Find the coordinates of the foci and the vertices, the eccentricity, and the length of the lattice rectum of the hyperbolas. So we have two equations of two different hyperbolas, and we have to find all of this for both of them. Pause the video, give this a try. Okay, let's do this together. Let's pick this one first. Let's compare this with the standard equation x squared by a squared minus y squared by b squared equals to 1. Here the coefficient of x squared is positive, which means the foci and the vertices will be on the x-axis. So on comparing, a is 4 and b is 3. Now when we know a and b, we can figure out c, that's equal to root of a square plus b square. That's going to be 5. Now that we have c, we can figure out the foci. That's going to be equal to plus minus c comma 0. c here is 5, so foci will be plus minus 5 comma 0. What about vertices? Vertices will be plus minus a comma 0. That's going to be plus minus 4 comma 0. Eccentricity is going to be c by a. That's going to be equal to 5 by 4. And we can see that it's greater than 1, which is the case for hyperbolas. What about the lattice rectum? That's equal to 2b square by a. So that's 2 times 3 square by 4. Cancelling 2 out, that's 9 by 2. So these are the things that we needed for this hyperbola. Let's move to the next one. 16x square minus 9y square equals to 576. First we divide everything by 576. So 576 by 16, that's going to be equal to 36. So this is x squared by 36 minus 576 by 9, that's 64. So the equation is x squared by 36 minus y squared by 64 equals to 1. Again, comparing with the standard equation x squared by a square minus y squared by b square equals to 1, we get that a is 6 and b is 8. It doesn't matter if a is greater than b or less than b. As long as the coefficient of x square is positive, the foci and vertices will be on the x-axis. So let's first figure out c. So c is square root of a square plus b square. That's going to be 6 square 36 plus 8 square 64. That's going to be 100. Root of 100 is 10. So c is 10. Now let's figure out the foci. That's going to be equal to plus minus 10 comma 0. Vertices plus minus 6 comma 0. Eccentricity, that's going to be equal to c by a. That's 10 by 6. Lattice rectum is 2b square by a. That's 2 times 8 square by 6. It's cancelling 2 out. That's 64 by 3. Let's take one more problem. 5y square minus 9x square equals to 36. Now this one's different. This has x square coefficient as minus 9, which is negative. This means the foci and vertices will be on the y-axis. Let's first convert it into standard form. Let's divide everything by 36. We have y square by 36 by 5 minus x square by 36 by 9. That's going to be equal to 4 equals to 1. Now this is y square by a square minus x square by b square equals to 1. Now on comparing, we get that a is equal to the root of 36 by 5. That's 6 by root 5. b is the root of 4. That's going to be equal to 2. And we can figure out c. c square is a square plus b square. That's equal to 36 by 5 plus 4. So c square is equal to 36 plus 20. That's 56 by 5. So c is root of 56 by 5. We can further simplify this. 56 is 4 times 14. So this becomes 2 root 14 by root 5. That's our c. Now once we have the c, we can figure out the foci and vertices. We have to be careful here. Foci and vertices are on the y-axis. So the coordinates are 0 comma plus minus c, which means 0 comma plus minus 2 root 14 by root 5. Vertices are 0 comma plus minus a, which is 0 comma plus minus 6 by root 5. What about the eccentricity? That's c by a. So that's 2 root 14 by root 5 divided by 6 by root 5. Root 5 cancels out. 2 by 6 is 1 by 3. So this becomes root 14 by 3. So that's our eccentricity. This is definitely greater than 1. Root 14 is between 3 and 4. So yeah, eccentricity is greater than 1. What about the lattice rectum? That's 2b square by a. So that's going to be equal to 2 times 2 square divided by a. That's 6 by root 5. So this is cancelling 2 out here. This is 4 times root 5 divided by 3. So 4 root 5 by 3.